In this chapter, we are going to understand the concept of classes in Java, which in essence is a building block of object-oriented programming. We'll start with the basics. What exactly is the class? We'll understand how a class acts as a blueprint for creating an object. Then we'll look at the anatomy or the structure of the class. We'll learn about the fields, the methods, the constructors, the access modifiers, and how these elements work together to define the behavior of the class. We'll explore different types of classes like abstract class, inner class, static classes, final class, and even interfaces, each serving unique purpose. We will discuss all of these concepts in their dedicated chapters. In this chapter, we are just gonna have an overlook about these concepts so that we are aware. We will also be discussing a code example where we'll be creating our first class for our banking system project. This will help us see how theory moves into the practical implementation. Beyond coding, we will spend some time understanding the philosophy of the class itself. That is how it promotes modularity, reusability, and maintainability, which are definitely critical factors while building large-scale systems. And finally, we'll go through some of the best practices and tips while creating and working with classes. By the end of this chapter, we'll have a strong foundation in how classes work, why they matter, and how to use them effectively in your Java projects. Let's get into it, shall we? So what are classes? Think of it as a blueprint or a template that defines two things. The first one is the structure of the object through its fields and attributes and properties, and the behavior of the object through its methods and functions. That is what an object can do. In short, a class definition describes what the object is and what it can do. To understand better, let's consider a real world analogy. Imagine you have a blueprint for your house. This blueprint is gonna tell us how many rooms it has, what the overall layout will look like, and what all things are gonna be included in that house. But blueprint is not the house itself. It's just a design. To live in it, you actually need to create a house from that blueprint, which is the concept of object. That is exactly how classes and objects work. A class is a blueprint, whereas an object is something real built out of that blueprint, which has memory allocated to itself. Let's look at the part of the instance creation quickly. A class in itself is not gonna occupy any memory. To use it, you need to instantiate that class, that is, create an object out of that class, and you can do that using the new keyword. When you do that, Java creates a new object. This is gonna be a runtime instance having its own memory, which is gonna follow the structure and the behavior defined by the class. You can create multiple objects from a single class. Each object will be sharing the same behavior, but it can hold its own unique data. For example, we can create two cars from a single car class. Both of the cars are gonna share the behavior, that is drive, stop, accelerate, but it is possible that one car could be red and the other car could be white. That is, the methods are going to be same, but the values stored for each object, they are independent from each other. Let's look at some of the key characteristics of classes. The first one is the encapsulation. A class bundles the data, that is fields, and the behavior, that is the methods, together into a single unit. Not only does that, but it also protects the internal state of an object by restricting direct access to the fields. We can instead use separate set of methods like getters and setters. These are gonna help you interact with these fields, getting the field value and setting the field value. Reusability. Once you define a class, you can reuse to create multiple objects from it, avoiding duplicate code. Inheritance. A class can inherit fields and properties from other class. This helps in reusing and extending the existing code, forming natural hierarchy in the code itself. Abstraction. Classes can hide unnecessary details and expose only what is important and as intended. This makes it easier to work with complex systems by focusing on what an object does rather than how it does it. Then we have objects. These are the runtime instances of the classes. You get an object when you instantiate a class. They hold their own set of values for the fields and can use the behavior defined in the class. To summarize, a class is a design, an object is a real world implementation of that design. Let's go through a structure of a class in Java. A class in Java isn't just a random block of code. It's neatly organized into different different components that define what the class represents and how it behaves. We first have fields. Fields are the data holders of the class. They represent the attributes or the properties of the objects created from that class. Each object is gonna have its own copy of these fields. For example, in a car class, fields might include the color, the manufacturing year, or the top speed. One car could be red, other could be blue. They are gonna have the same structure, but they can have different values for these fields. Then comes the methods. Methods are the actions or the behavior of the class. They operate on the data that is stored in the fields and they define what an object can do. Methods may return a value after execution, or they may perform a specific action without returning any value. For example, in the car class, we could have methods like drive, accelerate, or brake. So basically, if the fields define what an object is, methods define what an object does. Then we have constructors. Constructors are like special methods which are used to create and initialize objects. They are gonna have the same name as the class itself, and unlike regular methods, constructors are not going to return any value, not even void. Their main job is to make sure that when you create an object, it is in a valid and a usable state. For example, for a car class, a constructor with the same name as car can be used to set the initial values of the field variables like color and the manufacturing year the moment when you create a new object from that class. Then comes access modifiers. They help control the visibility of the parts of your program, that is, who can access the fields and the methods of that class. We have three access modifiers here: the public, the classes, the fields, the variables, the methods which are defined as public can be accessed from anywhere in the code. If all of those are defined as private, they are accessible only from that particular class itself. And when they are defined as protected, they are accessible from the same package or the subclasses present in that package. Using access modifiers helps us implement encapsulation and protects internal state of the object. So the takeaway here is every class in Java typically includes fields for data, methods for behavior, constructor for initialization, access modifiers for security and structure, and together these make class a well-organized blueprint for creating real-world objects. Java does give us different types of classes to work with, each serving a different purpose. Let's quickly go through them one by one. The first one is the concrete class. This is the most common type of class which you're gonna use. It's a regular class which you can instantiate and create objects from. In this case, for example, from the class car, we can create a new object here. My car here is the new object which we have created, and we are using new keyword here, and we are passing two values here, one for the color and other for the model. So it is going to create a new object which is going to have two fields, red as color and Tesla as model. In this case, the car class was a concrete class, and my car here is the object which we have created from that concrete class. Then comes an abstract class which you cannot instantiate directly, that is, you cannot create objects for the abstract class. The purpose of this class is to act as a base class for other concrete classes. It can contain both abstract methods and concrete methods. Abstract methods are the ones which don't have any execution body. You just define the name of the method here, whereas concrete methods are something which have functional body to it. Let's consider an abstract class animal here. Animals are gonna make sound, so we just define an abstract void make sound method, and we also define a method called sleep. This is just printing out that the animal is sleeping. Now this is an abstract method here because it doesn't have any body. This is a concrete method here because it has a body of a single print statement. So what happens with this abstract method here? So any class which is gonna use this animal class as a base class, it's going to get that make sound method, and it's going to add its own implementation of it. If we create a new class for dog, and let's say that concrete class dog is using this abstract class animal, the concrete class dog needs to provide a concrete implementation for the make sound method. In this case, the dog is gonna bark, the bird is gonna chirp. So each animal is going to have a different implementation of the the makeSound method. That is the core idea behind the abstract class. You just define the method and you let the individual concrete classes which are gonna use this abstract class, they can have their own implementation of this makeSound method. Then we have inner class. This is a class defined inside other class. It is useful for grouping the classes which are related together. An inner class can access the fields and the variables of the outer class. And then we have final class. This is a class which cannot be extended. We'll understand the concept of extending a class in the chapter of inheritance. The concept here is once we define a class as final with a final keyword, no other class can inherit properties from this final class. This is useful when you want to prevent any modifications through inheritance. Then comes an interface. An interface is not a class per se, but it defines a contract that other classes must follow. We'll understand the concept of contracts in the upcoming chapters where we will be discussing interface using a practical implementation to understand it better. For now, just remember all of the methods inside an interface are going to be abstract by default, and a class that implements that interface must provide implementation to all of those abstract methods. Don't worry about the concept of inheritance, abstract class, interfaces. We will discuss all of these concepts in detail in their own dedicated chapters. Classes are not just technical feature of Java. They represent a philosophy of software design rooted in object-oriented programming. The goal here is to make the software more organized, reusable, maintainable, and closer to how we think in real world. Let's break down some key philosophies behind using a class. Encapsulation, that is hiding the internal state. A class combines fields, that is data, and the methods, that is the behavior, into a single unit. We can also control the access to these elements using the access modifiers like public, private, and protected. It protects data from unintended changes and it improves the overall security which a class offers. We can define getters and setters method while interacting with these fields rather than touching on these fields directly. Then comes the abstraction, which is simplifying the overall complexity. Classes expose only what is necessary while hiding all of the unnecessary internal details. It makes the overall system easier to understand. Just like driving a car, you just drive the car. You don't need to understand how it is working under the hood. You just need the steering wheel, the accelerator, and the brakes. Then comes the modularity aspect of it, which helps us organize the code. Each class is responsible for one specific defined purpose. By keeping these responsibilities separate, the system becomes easier to read, understand, maintain, and debug. Then comes the factor of reusability, that is write once and use it multiple times. Once you define a class, you can reuse it anywhere within the same program or even different projects. It saves efforts and prevents the overall code duplication. Then comes inheritance, that is building on what already exists. The class can inherit properties and methods from a class which is already created. This basically encourages the code reuse and extension. Instead of rewriting the whole logic for a class, you can just extend the class which is already there and you can add additional fields and methods to it based on what you need from it. Then comes the polymorphism, that is one interface and many implementation. Different classes can be treated as the same type if they share a common parent or an interface. That is, there is going to be a single interface which can be implemented by the multiple classes and they can have their own set of functional logic for the methods defined in the interface. So that is how you're going to achieve the concept of polymorphism, that is one interface and multiple implementations. It helps make your code flexible. Then we have separation of concerns, that is decoupling the responsibilities. Classes can separate different aspects of a system. There could be different classes for handling data, for handling business logic, or the user interaction. There are going to be different classes for each responsibilities, and changes in one class is gonna have minimal impact on the other class, which makes the overall maintenance easier. What it means is classes mirror real world entities like an account number, a customer detail, or a car. And even the non-technical stakeholders can understand the system design when it reflects real-world concepts. This makes programming intuitive. Then comes the factor of maintainability, that is improving the overall code quality. Classes can help break large, complex code bases into smaller, manageable units. This helps developers fix the code or improve a class without breaking the entire application. And lastly comes the factor of extensibility, that is supporting future growth. Classes can and should be designed to be extended or modified so that as requirements change, you can keep adding new features without rewriting the entire application. In this way, your system can evolve over time. To sum it up, the philosophy of using classes is more than just syntax. It's about creating clean, modular, reusable, and extensible system. By aligning with the object-oriented principles like the encapsulation, the abstraction, the inheritance, the polymorphism, classes empower the developers to write softwares that are easy to build today, easy to maintain tomorrow, and ready to scale in future. Now let's discuss the code example to see how to practically implement a class. But before that, this is something I would like to share with you. This is a website called draw.io. This is where you can create class diagrams so that you can visualize the entire project in a much better way. That is what I've done for this particular chapter. I've created a class diagram here. So in this case, we have the blueprint class. We have BankAccount as the concrete class, and it has its own set of fields like string account number, double balance, and string account holder name. And it also has its own set of methods to work with, like the void deposit, the void withdraw, and the void check balance. Here, if you see the deposit and the withdraw, they are going to take input parameters as amount, because we need to know how much amount needs to be deposited into an account, how much amount needs to be withdrawn from an account. And then we have the check balance. This is not going to take any input parameter because it's just going to check the balance for a particular account number. So this is a most simplest form of concrete class we can come up with. We will be adding more classes and increasing the complexity in this diagram as we keep understanding the next chapters. Let's just go to the actual code example. Since we are done with the basics, now we are creating a new project here. This is the object-oriented programming project. I'm going to keep it all as default and next and finish. So here we see we have this new project created and we don't need this module.info. We can delete it. We can start creating our new class here. This will be our first class of banking project. I'm going to name it as BankAccount. We don't need main method for it because we are not going to use main method in this particular class. So we have a simple blank class here created, and now we can add the fields which we have discussed. Each bank account object is going to have an account number, a balance, and an account holder name. Let's add some methods to this particular concrete class. Here, this is the first method which we have created. This is a deposit method. It is going to take input parameter as amount, double amount. It's not an integer amount because it's going to have a decimal value. So we are using double amount as an input parameter. And here we are performing a check using if condition. If amount is greater than 0, then we need to add that amount. We are doing that using the compound assignment operator here. We are adding that amount into this already existing balance, and we are just simply printing out that this amount has been deposited. Whereas if this condition stands false, then it is going to be invalid deposit amount, because you cannot deposit amount which is equal to or less than 0, that is negative. So that doesn't work. That is why in the else condition we have given it as the invalid deposit amount. We have a second method here to withdraw. It is again going to take an input parameter of the double amount, and here we are going to perform an additional check, that is if amount is greater than 0. Obviously you cannot withdraw 0 and the negative amounts, so the amount needs to be greater than 0. This is going to check if both the conditions are true. The second condition here is amount is less than equal to balance. That is the amount which needs to be withdrawn definitely needs to be less than or equal to the balance which is available in the account. So that is the condition we are evaluating using the and. This makes sure that both of these conditions are evaluated to be true. If and only if that's the case, case, then this block is going to debit that amount from the existing balance and it is going to print out that withdrawn amount. And if this condition is false, like even if one of these condition is false, then the else block is executed and it just displays a message that invalid withdrawal amount or insufficient funds. And finally, we have the last method here, the check balance. This is simply going to print out the current balance value for that particular bank account object. And that is about this class. So even if I save the program and run, nothing is happening because nothing actually is happening. We have just defined a basic class. We have just added fields and methods to work with. Now we need to create an object of this class and then assign values to these fields and then deposit and then call these methods using that object to deposit money, to withdraw money, or to check balance. And that is all about the code example. Use proper naming convention. Class names should always be like a noun and they should always be written in camel case naming convention. A good name for the class gives a good idea about what that class is all about. Encapsulate data with access modifiers. Use public, private, protected based on the problem statement you have. If you want to protect a value, set it as a private and use different getter and setter methods to access and update that value. We will look at what getters and setters methods are in the next chapter where we discuss the concept of object. Follow single responsibility principle. That is, a class needs to be simple and focused on just one purpose and responsibility. If it's doing too much, break it down into smaller and focused classes. Keep the methods short and focused. Each method should handle only one task. If it's long or if it's doing a lot of things, consider breaking them down into smaller helper methods. Use constructors for proper initialization. We'll see what constructors are and how to actually use them. But for now, let's just remember, when you are going to create a new object, you can use constructors to initialize values for it. Avoid exposing fields directly. That is, never create fields using public access modifier. Rather, keep them protected or private so that you can control the access to those fields. Follow the dry principle. That is, don't repeat yourself. If there is a lot of code which looks like it's repetitive, you can arrange all that code into its own method or its own class. Write Java doc comments. That is, always document your classes using comments so that it's helpful to understand what is the purpose of that class and what that class represents. By following these practices, you can define classes that are encapsulated and secure, reusable and clean, modular and easy to maintain, and ready to grow as your project scales up. A good class isn't just about writing specific piece of code, it is about writing the code which lasts longer. That brings us to the ending of this chapter. We understood what a class is and how it acts as a blueprint for the objects. We understood the structure of the class, including the fields, the methods, the constructors, and the access modifiers. We understood different types of classes. We understood the philosophy behind the classes and how they promote encapsulation, abstraction, inheritance, modularity, and reusability. We also went through some of the best practices and tips for writing clean, maintainable, and extendable class designs. By now, you should be comfortable with the idea that classes are not just code, they are a way to model real-world entities and behavior in a structured and a scalable way. Up next, in the chapter 14, we will understand the concept of objects. We'll shift our focus from the blueprint to the actual implementation of that blueprint in the form of objects we can create from the class. We'll learn how objects work, how they interact with each other, and how they bring your Java programs to life. And that's about this chapter. I'm Venkatesh Mudalia. Till I see you again in the next one. Cheers.